We had a talk about this, and even chapter 9 and 10 about this open point and then the non-open point or non-control point. Dumping the pollutants inside the environment. It has two sources. One source which is very controlled, that's non-point. Non-point means you know the factories, you know the area, you know the companies they are, what they are doing, what they are manufacturing, what they are putting inside the air of pollutants. That's straightforward. But the problem is with non-point sources, you don't know. And I told you what's happened in our stream at the Clarkston Campus. We have a lot of empty car oil left over inside. We have a lot of tires. We have a lot of, junky stuff, which really affecting the quality of the tap water and affecting the dissolved oxygen inside that layer and that stream. So that stream is feeding the whole botanical garden. The botanical garden, it goes through the botanical garden and it's feeding the whole area there. Animals, we have a lot of deers in that area. We have a lot of animals as well there. So, but the decap count is the top of it. So we use our students to extra credit to come and help to take the stuff. We go with them, and the cap count then will help us with a lot of heavy machines to clean up the stream every semester, once a semester. But they come before that, they kind of get all the old stuff out. So the non-point source are often harder to control because you don't know who had done what, unless you have to put cameras and put a lot of stuff. It's very hard. But the open point or source, that's very easy because you are dealing with registered companies. They know what they are, you know what they are manufacturing, and you know what type of chemicals, what type of pollutants they can afford to dump it inside the air or the lakes or the ponds or the rivers. Tremendous challenge of managing those sources because you don't know who those people are and what they are doing. Nutrition pollution had degraded that bay. This speaks about the Chesapeake Bay and the implementation of pollution prevention measures and planting of seagrasses and wetland has helped. So you will see when we go to chapter 9 and 11 with the air pollution, that's the same problem with the tap water pollution. You have open points, that's registered factories and companies, and you have non-registered one, they call it non-point sources of pollution. The same with the air pollution. Municipal treatment has 3 levels of quality. See here. Now, before that, how do we treat municipal waste? We talked about this. I told you each county has this tap water treatment plants, and as I said, it's very expensive to maintain, but you have to have it. You have to have it. And the quality of tap water is very nice, and it's equivalent to whatever you have the bottled tap water there. So there's no difference between them. I told you about this, and the author is really put emphasis in the same way I did. So that the plant, the treatment, tap water water treatment is very important, and it's really helping. As you see here, municipal water treatment here, this is very helping to have this tap water recycled, this type of recycling tap water. So you are not losing tap water, but it will be recycled back to the users. Most rural households use septic system, which allows solid settles in a tank where bacteria can decompose them. Municipal treatment has 3 levels of quality. that's speaking about the water Tabor treatment plant. They have three types of treatment. First of all, they take the big ones, the solid ones out, the solid particulates waste out. Then they treat them with they break them with bacteria, okay, and then the tertiary they remove all the chemicals or chemical compounds such as phosphate, nitrates, all those. So three treatments. First of all, the physical big bulky solids and from the waste, and then they use some bacteria to act in this, and then the tertiary treatment, that's chemically based treatment, so they can remove all the chemicals there that's really hazardous for the environment and the soil. Conventional treatment, Mrs. New pollutants, well, you cannot be 100% sure that you will get all the pollutants out of your way. So, and as you can see, USGS 2002 released the first ever study of pharmaceutical and hormones in the stream. They found in small amount traces of hormones, traces of detergents, plastics, insecticides, and the pesticides. All those are found in a small amount, not a larger amount. So that's good because you are dealing those are coming mostly from the open point, from open source. That's from the manufacturing companies. What are the effects of these widely used chemicals in our environment? Well, nobody really knows. If they, as long as they are in small amount, their effect is contained and controlled. But if they accumulate through the years, then there will be a little bit too much of risk brought with the amount, with their increasing amount in the environment. Remediation can involve containment, extraction, or biological treatment, and as well a chemical too. So often living organisms can clean up contaminated Tabor. We call this bioremediation. We can use special fungi or bacteria can really decompose some of those contamination in Tabor, correct? Restored wetlands, for instance, along stream banks or lakes margins can effectively filter out sediments and remove pollutants. And some plants are very efficient at taking up heavy metals and organic contaminants. Bioremediation offers exciting and inexpensive alternative to conventional cleanup. So cleanup in itself, conventional cleanup costs a lot of money, very, very expensive, correct? Very, very expensive. Legal protections for Tabor, well, I think we talked about the Air Act mandate and the Water Act mandate. Those goes hand by hand, and they have a lot of advantage on controlling how much pollution for the air and Tabor is allowed to be dumped inside the environment. So water pollution control has been among the most broadly popular and effective of all environmental legislation in the United States. It has not been without controversy, however. So, well, some people, they'll say, has not effect. Like people, they don't believe in global warming. It has an effect on our life, on our environment. Some people do, but when you go back to the data will tell you there is a global warming. There is 0.5 degree Celsius, 1 degree Fahrenheit, or about 1.5 degrees increased in about 11 years. You get all these degrees are increased. So there is global warming. But again, this is people, they don't believe that it has an effect on our life. In 1972, there's Clean Water Act, which is very close to the air, as you'll see, Air Clean Act in that time. So, in that time was the Air Clean Air Act is there, was published or established. So, and they are very, very tough on the companies or factories or power plants, nuclear plants, if they are dumping any pollution without telling, without recording how much they have put into the environment and what type of pollutants they are dealing with. So, and they can be their permit can be revoked, and the factory can be shut down. The permit requires disclosure of what is being dumped and gives regulators valuable data and evidence for litigation. So this is very important to know what you are dumping and how much, type and the amount. So it's very important to know. And this is for the open point, means you know the source of this pollution for the tap water. And this is the same thing as you'll see for the air pollution. The Clean Tap Water Act was ambitious, popular, and largely successful. You'll see along of Endangered Species Act and the Clean Air Act is one of the most significant and effective pieces of environmental legislation ever passed by the U.S. Congress. The ambitious goal of the Clean Tap Water Act was to return all U.S. surface water to fishable and swimmable conditions. So, as to tell you the truth, you lived in Europe, most of the ponds and lakes and rivers in Europe, you cannot really swim in them, you cannot eat the fish in the most of the rivers there. You cannot. It's so polluted. I mean, it will take a lot of money to clean up those rivers. Areas of progress. Well, 10% of our tap water pollution now is coming from the industry, as I said, from open point sources. You'll not see that much 20, 30 years ago. It was more than, as I said, in Europe, more than this 10% pollution. It's the rivers there. You cannot, as I said, swim. You cannot really swim. You cannot eat the fish over there. So one of the biggest environment improvement has been in this sewer system. Nearly everyone in urban areas is now served by the municipal sewer system, which is connected to the tap water treatment plant. So, and no major city discharge raw sewer system inside the river or lakes or ponds. That was not now that's not the case. It's very difficult. You can see most of our rivers much by far better than the European or any places else, because there's a lot of controlled rules and regulations really prohibiting dumping stuff inside those lakes and rivers and ponds. So I think that's chapter 11, and this is a summary of chapter 11. Tap water is very precious resources. As human population grow, tap water likely becomes more scarce in the future. Conflicts over tap water is always very dominant in developed countries, and U.S. federal and state and local pollution controls have greatly improved our tap water quality in most places, especially in rivers, lakes, ponds. In rapidly developing countries such as China and India, tap water pollution remains a serious threat. Constructed wetland for ecological sewer system provide a low-tech, inexpensive ways to reduce pollution. That's the whole summary of the whole chapter. I'll stop here, and then you allow me to just